This is a brief video tutorial of the operation of the data collection apparatus that is associated with the single photon avalanche photodetector lab. There are a particular number of diodes, LEDs, that when placed in reverse bias will detect single photons of light. In this case, this LED is an AND113R or AND113RP, and when it is held from about 25 to 27 volts of reverse bias, it will output single photon pulses, or pulses that are indicative of single photon arrivals. Right now I have it at about 24.8 volts of reverse bias, and with this orange wire I am probing the output. This corresponds to the yellow trace on the oscilloscope, and we have these single photon arrivals. You are going to construct a circuit, a discriminator circuit, from a comparator integrated circuit that converts this pulse into a digital signal. And the way it does this is it compares the incoming voltage with this orange wire to a set voltage, or a voltage set by this potentiometer. So when the voltage goes above a particular set point, say right around there, the output of this integrated circuit, or IC, will go high, and when it falls below this voltage, right about there, the output will go low, and we can digitize the signal and then analyze the resulting data. So let me just demonstrate here. If I turn this potentiometer clockwise, the discriminator voltage goes up and the output pulse becomes narrower. As I turn it down, the discriminator voltage gets lower and the output pulse becomes wider. So set that to an appropriate value and then go about your day. So let's talk about how to actually collect data with this microcontroller. There are two buttons. The right button is the frequency data for frequency data collection, and the left button is for time interval data collection. The microcontroller enumerates as a keyboard, so it can output data directly to an Excel spreadsheet, for example. So let's just take some frequency data and talk about the output. So make sure that you have a cell selected in your spreadsheet, and let's press the button. The green LED will illuminate, and as you can see, it is populating the spreadsheet with data. You may take several hundred data points. It's good not to click anywhere else, because as soon as you click someplace else on the spreadsheet, it will start collecting data from that point. So just leave it in a constant illuminated position. You can see, of course, that if I cover this, the frequency will go down, and if I put more light on it, the frequency would go up, making sure that it is a photodetector, or it is detecting light. Another issue, we want to keep this frequency somewhere between maybe 500 pulses per second to a maximum of 10,000. We definitely don't want to go above 10,000. So you can adjust the bias voltage, or the voltage, the reverse bias voltage of this LED. Right now, like I said, it's about 24.8. I'm going to increase this a little bit, and you can see that it goes up to 5,000. Again, you have to keep that below probably around 8,000 for this to function properly for technical reasons. I think it's a good idea to keep it between 1 and 5,000. So let's just decrease this to around 1,000 pulses per second. And when you click this button again, it will cease to collect data, and the green LED will go off, and it will return to the top of the spreadsheet. And there you have it. To take interval data, it's a little bit more complicated. for the microcontroller, not necessarily for you. It collects data over 2 seconds. So I'm just going to press this once. The red light will illuminate for 2 seconds, and then it will spit out data to this spreadsheet. So let's again select a cell right here. I'm going to click this button, and it will take 2 seconds of data, and then it will spit out the interval data. This may take a little bit. The reason that the data collection has to occur this way is that the keyboard can only support 500 key presses per second. So it has to collect 2 seconds of data very quickly, and then it spits it all out over the course of however much time it takes to populate this spreadsheet. Again, I would remind you not to click on any other thing while it is outputting, because it may mess up whatever you are trying to do with your cursor. Well, I hope that's a decent introduction to the single photon Avalanche photodetector lab, and good luck with your experimental endeavor, spelled with a U.